you go back and you start thinking about where we're at, guys, as of right now, we've done stuff like this. We have a good old-fashioned right triangle. Say this is 53 degrees, and we'll make this 17. I'm just making stuff up. And you want to go? Yeah, it should be. Just setting up. It only took everything. What we've done up to this point is that we've done here's a right triangle. We circled our angle, figured out a specific side. But now what we're going to do today is we're going to solve for everything. All right. Now, what I'm going to do here today is to start out with, I'm going to label our triangles. And when we have our triangles, we're going to have one of two scenarios. We're either going to be given an angle and a side, or we're going to be given two sides. And then from that information, you'll be able to have to figure out, well, either two angles and a side, or in this case, one angle and two sides. So now what we're going to do is we're just calling this solve the triangle. And what that means is that you're going to find all missing parts by using given information. Okay. We're going to use our given information to find all of the missing parts. This is quite literally adding one step to all the problems that we've done so far. So far, all the problems were, oh, find this missing side, or find this one missing angle. Now it's just find an extra side, or find an extra angle. It's going to be relatively quick and painless. It also goes back to the idea of remembering SOHCAHTOA. As we go through, before we get too far, I'm looking at solving triangles today. If we need an extra day tomorrow, it's not that big of a deal. I don't see that being a problem, but I kind of think we'll be able to get into what's called angles of elevation and depression tomorrow. I think we'll be able to do that. Monday's a big iffy. I still don't know for certain if I'm going to be here. I could be at jury duty. So, yes, sir. Yes, sir. It's the angles of elevation and angles of depression. It's line of sight looking up or line of sight looking down. So come Monday, that's kind of why I wanted to get into a little bit of this angle of elevation stuff here, so that we would have to start something new without me being around. So that way we can kind of feed into this. So this is still I don't know. It's kind of like, I'll find out Sunday night, and if I'm not going to, yeah, I got a call in, I think at like 5 o'clock on Sunday night. So if I get a call, then I'll post something online. I'll send you guys all an email, let you know what's going on. And if it happens to be where I'm not going to be around, I'll have, I've already made worksheets, so I don't have to come in first thing Monday morning to do anything. I'll have something ready for you guys, just kind of review them. So it won't be a big deal, but it's kind of like I don't know. Still kind of wondering if they're going to select me because I know too many police officers. Kind of want to go, though. Just go. But anyway, so that's kind of where we're at. So we're kind of in that weird setup here. Next week is a full week, though, if I'm not mistaken, correct? It's the following week we have a half day somewhere in there. I don't think we're going to have any issues, bear in mind if I'm around, probably testing midweek here, Wednesday, Thursday, I'm guessing, of that week. And then what we'll do is we'll talk about what's called the law of sines, law of cosines. And I like to do that after right triangles because it isn't something that you have to worry about with right triangles. So, and that's usually like a quick little day and a half, 2-day type thing, and we usually do a really easy quiz over just that material. That's generally speaking, it's been a really good booster of a grade for most people when we get to that. Just so you guys know, that's kind of the idea. This is kind of in the air. Gotta love not knowing for certain about things. So just so you know there. All right. So what we're gonna do here is what I'm gonna keep reiterating is this bit here, reusing your given information. What I mean by doing that is if you use the given information, and let's say you get a part wrong. If you use a wrong part to find the next part, will that part ever be right? No. But if you reuse something, you have a chance of getting it right for a different portion. That's huge with trig. Okay? It is so easy. You guys can attest to this. You can hit the wrong button. You can hit the wrong thing. It's super simple. But it's one of those things, I just want to make sure that we understand, what am I going to do to set up and solve here? So going to this problem here, what are the three things you have to solve for? What's the angle you have to find? We have to find angle C, side AB, and then we have to find side BC. So the first thing I'm going to ask that you guys do is you're going to label the parts you have to find. And the order you put the parts down isn't that big of a deal. But whether it's the angle or the sides or two sides, it doesn't matter the order. But I want you to get accustomed to seeing what you have to find. Because think of that as it's like a checklist for you to make sure you're doing the problem correctly. The problems that I have made for us for today, I've started with most of them listing out the parts that you need to find. But over time, I kind of take back some of those. You'll have to start writing them out yourself. So you'll start to see it's not going to be all that difficult. What is the easiest thing to find here first? Which one? The angle. What's the angle going to have to be here for angle C? 37. Why is it not 47? You guys made this mistake a lot last week. You have to add the 90. Remember that? The angle, there's two angles that are not right have to add up to equal 90. So the first thing we'll do is we know that we can take 90, subtract the 53. We get 37 degrees for that. Right? And just put it off to the side. So now we go through our trig functions. If I circle my angle, I draw to my opposite. There's my hypotenuse. Makes my adjacent. Which means in order to solve for side BC, I'm going to use what trig function? And to solve for side AB, what trig function? Reusing your given, what am I going to use for AB? Cosine, very good. See how I'm reusing the given information to go to both parts. Okay. So what we do is we write it out, just like we have been. Sine of 53, in this case is now section BC over 17. Cosine of 53 is section AB over 17. And see how it's leading us to doing exactly the same thing we have been all along. It hasn't changed. And that's what's really nice about trig. As you get going into it, it's the same problem over and over again with different numbers. If you want, that's fine. The reason why I'm writing it like that, Josh, is so that way you know what portion you just solved for. And you're going to see that a lot. I'm going to try to use what sections they are because you're going to substitute those back into the problem. Yeah, Sean? Because in order to solve, if I'm not looking at this part to start with, if I'm not worried about the adjacent portion here, in order to solve for an opposite using a hypotenuse, what trig function is that? It's going to be sine. Oh, turn it off. In order to solve for an adjacent with a hypotenuse, I use cosine. So in these cases, you're going to use two parts. So you're going to do, it's basically, if instead of having 10 problems, you have 20 problems. See where I'm going with that? So now it's just a matter of putting that we know that it's going to be 17 sine of 53 is BC, and then 17 cosine of 53 is AB. So we press a couple of buttons. So we press a couple of buttons on the calculator real quick. Round to two decimal places like you guys have been. And for the sine, I am getting I get those two values. And Josh, the other reason why we write them out, that way we put them in the correct spot, so that way we know that across from the largest angle is the largest side, the smallest angle is the smallest side, things like that. It's that little attention to detail. Okay? And that's what you have. Not too terrible, is it? I'm hoping. Yes, no, maybe so. It's quite literally the exact same thing we have been working on. It's just adding the step. Right. Remember, pressing buttons at the very end after you write down what you have. Let's try another one. Let's try the version of when you have two sides. So in this case, we have two sides, which means we have to find one side and two angles. And one of the things I want you guys to remember is anytime that you have two sides of a right triangle, what's the absolute easiest way to remember or how to solve for the third side? Exactly, very good. Pythagorean theorem. Always use the Pythagorean theorem if you have two sides of a right triangle. It's the easiest way to do it. So in this case, we have a 10 and a 26. Which one of those, or do let me rephrase that. Do we have a hypotenuse? Yeah. Which one's the hypotenuse? Good. So we just write out our Pythagorean theorem using 26 as the value of c for the hypotenuse. And we get 10 squared plus bc squared is 26 squared. Take the square root of whatever that is. We're going to type that all through. Let's see what we got. Let's see here. We have 26 squared, subtract 10 squared, hit enter, take the square root of my answer. I'm getting 24. Anybody else? Make sure you have your calculator out so that way you practice pressing buttons so you don't screw something up later. So that's fine. I found my missing side. Okay. Notice, I did not put that on the triangle. You know why? What if I screwed up? Then I'd be wrong when I try to find my angle. So now, by just putting it off to the side and labeling it, I'm going to go through the process like we have been. Do you guys want to solve for angle A or angle C first, or does it matter? No, it doesn't matter. Well, let's start with A. If I start with angle A, I circle it just like we have been. I draw to my opposite. I have no info, but I have an adjacent and a hypotenuse. What trig function will allow me to find angle A if I know the adjacent and the hypotenuse? Cosine. So we know that the cosine of A is 10 over 26. How do we write for angle A when we're trying to undo something? Inverse, very good. Remember the inverse button? Whenever you're trying to find the angle is the only time that you're going to press the inverse button. Otherwise, something's going to really get screwed up. Okay, press some buttons and go from there. We do the exact same thing to solve for C then. If I go to C, remember how we talked about this last week where we had, I forgot what problem it was we did. Or was that Tuesday? It might have been Tuesday. Where we had the one problem where I showed you that now C is looking at the side of 10. It is not the adjacent anymore. It's now the opposite. So it changes. Remember we talked about trig is about perspective? As you switch angles, your opposites and adjacents will switch. Okay? Does the hypotenuse ever change? No. No. Now to find angle C, what trig function am I going to use? Sine. Oh. Okay, you do that. Now going backwards off of that, the inverse to get the angle by itself, we hit the button that says inverse sine. So your angle C will become the inverse sine of that 10 over Again, we wrote everything out before we pressed any buttons because it's the easiest way to not screw up. Let's see here. Inverse sine 10 over 26.
22.62.
Very good. Inverse cosine 10 over 26. 67.38.
And if you add 67.38 and 22.62, what should you get? Do we?
Make sure you put them where they belong. Pretty quick and painless, isn't it? Albeit it seems like it's more work, it really isn't. It really isn't. Let's try to. Let's do. Girl, give me a number.
14.
All right, you guys. Let's try to remember grab all of it at the same time. You guys figure out what do you have to solve for. Make your list, write it up, and solve. We'll check in a couple minutes. So I'm guessing we're mathing really, really difficult. Am I right? Assuming that this is like really, really hard, and you guys are all scared and all crying on the inside, and really sad, and upset, and just more so than ever, you don't want him here because Trig is just an evil, evil person. The reason why is because we take our time, so that's the whole point. What are the three things you have to find? For shame. We got to find angle A, AC, and BC. Well, of those three things, what's the easiest to find? Angle A. So if I take 90, subtract 14, you get what? 46, or I'm sorry, excuse me, 76 if I'm not mistaken? Okay. I leave it off to the side there because that way I don't accidentally reuse it. I just accidentally said 46, if I wrote 46 and use it, screwed, it never worked. So we go back to what we've been doing. Draw to your opposite, hypotenuse, and adjacent. Which two trig functions am I going to use? Well, what's the first trig function I use to find the opposite? Or excuse me, the hypotenuse. Sine, and what am I going to use to find the adjacent? Very good. So we're going to use, to get the hypotenuse, is going to be the sine of 14. It'll be 34 over, in this case, it's AC. And then the adjacent is the tangent, which is 34 over BC. In both of these problems, the unknown is in the denominator, which means we do the good old-fashioned exchange-o-change-o, or switcheroo if you'd like. So AC will equal 34 over the sine of 14. And then BC will equal 34 over the tangent of 14. And at that point, you have everything written out prior to pushing the buttons, which means you are 99% correct. You know. I am getting, for AC, I get 140.54. Okay with that? And then for BC, oh, I did times. I was going to say something different, right? 136.37. Originally, I looked at my calculator and I had an answer of 8.48. Why can't BC be 8.48? Yes, sir.
It's way too small.
Yeah, it's too small. It's got it. If it was 8.48, that would be the smallest side length. What does the smallest side length have to be across from? The smallest angle. 14 would have been the smallest angle. So I knew right away when I saw that number, ooh, I screwed something up, which meant I double checked it. I accidentally multiplied by the tangent instead of dividing. So those are the kind of things you got to double check yourself. That's why we write everything out so we don't make that dumb mistake. Not too bad, is it? Hooray, math! Let's do some problems. Now, originally when I was making all these problems out, I'm like, hey, you know what, we should have a lot of problems and just do this over and over again, like the good old-fashioned drill and kill. And then I'm like, well, that sounds stupid. So let's just do evens. Is that not count? I don't like it. Finally. So let's do the evens on this one. You guys will notice that on this page, some of them have written out for you what side lengths or angles you are looking for, but then some of them don't. So as you get to like number 8, number 10, 14, 16, 18, and 20, there you'll have some that you'll have to actually write down what it is in fact you're looking for. I figured by mixing it up to start with by showing, hey, make sure you're finding these specific parts, you'll get more accustomed to writing it out on your own. So we'll just do the evens on this, and we'll have no problem talking about what's called angles of elevation and depression stuff tomorrow. Yeah. Just the evens, there's just 10 of them. You'll probably, I mean, in all honesty, you're going to have 7 of them done before you walk out this door. At least I hope. All right, get cracking. Well, in this case, you're just like we're doing. You look at what you have. You got side AB, side BC. What else do you find? Side AC, and find an angle. So you see. So what you're doing is you're making a list of what you need to find. No problem. Also, just a quick reminder, so we have this. Write this on everything that you get. Reuse your givens, please.